Hello students, how are you? I hope you are all doing well. So today we will study force between two parallel currents. Okay. So basically what here in this topic what we will see, we will take two conductors and we will assume that there are currents are like the currents are flowing in these two conductors. Like if we'll take two conductor wires, so the parallel currents means the in the same direction currents are flowing in these two conductors. Okay, so we'll study that what is the magnetic force acting due to one conductor wire to due to one conductor wire on another conductor wire, and similarly for the due to another conductor wire on the first conductor, that we will see. So first of all, let me draw the two conductors. This is the first conductor wire, and then there is the another conductor wire. Okay, the thing is they are parallel to each other, and let's say the current I1, or we can say the current I1 is flowing in the first conductor wire, and current I2 is flowing in the second conductor wire. Now, our task is to find out the force due to first conductor on second conductor, and the force due to second conductor on first conductor. That we are going to find out. And let's say their length is L. Okay. So, for example, their length is L and the distance between them is small d. Okay. Let me write here. The distance between them one second. The distance between them is small d. Okay. So distance between them is small d. And now we are going to see that what is the force due to first conductor on second conductor. So if the current I1 is flowing in the first conductor wire, then due to that there will be a magnetic field uh, on the side of current I2. Okay, how to determine that? We have an equation that magnetic field due to a straight conductor wire is nothing but mu naught I upon 2 pi d. That we'll do in the later on, we can say derivations. But first of all, we should know the direction of that uh, magnetic field. So here we are going to take the coordinate axis. Wait. Here we are going to take the coordinate axis like this: x, y, and z. Okay, so this is the coordinate axis we are going to take. So here, as per the right hand thumb rule, what we can see, the direction of magnetic field due to first conductor wire is, if we hold the first conductor wire in our right hand, then the direction of the thumb and the direction of the current should be same. So it is in the upward direction. Now the direction of magnetic field will be along the direction of curved fingers. So towards the we can say towards the second conductor wire, the direction of magnetic field is into the page. Okay, into the page means in the minus z cap direction. Okay, so here let me write. First of all, first one, the magnetic field due to first conductor towards second conductor. What is the magnetic field due to first conductor towards the second conductor? It is nothing but B1 equals to mu naught I1 upon 2 pi d, and the direction will be minus kk. Okay, minus kk, or we can say minus zk, both are same. So here the direction of magnetic field due to first conductor towards the second conductor is mu naught I1 upon 2 pi d minus kk. Now we want to find out the force due to uh, force the force due to a straight conductor wire on the like the first conductor wire on the second conductor wire. So that will be F12. Okay. So the force will be now the force, the magnetic force actually, magnetic force due to conductor 1 on conductor 2. Okay, so force due to conductor 1 on conductor 2, that can be written as F vector 1 2. Okay, because force due to conductor 1 on conductor 2, that can be written as F12. Okay, so now that will be basically as per the, we can say we know that one formula, that is ILB. Okay, where the actual formula is like the current will be I2, because we are going to find out the force on the second conductor. So the current will be of the second conductor I2, and L vector cross the magnetic field of the first conductor wire. Okay, so here we are assuming that the length is assuming length of the conductor is L. Okay, if the length of the conductor is L, then L vector will be in the, we can say the direction of L vector, or we can say the length vector will be in the same direction same direction as the current is following. Okay, this current is following in the upward direction, that means plus j cap direction. So the L vector will be, so therefore small L vector will be nothing but L into j cap. Okay, this will be the direction. And now we will put the put the expression of B1 vector, and the current will be I2 as I2. So now, therefore, the force will be nothing but F1 vector, F12 vector, F vector 12 will be equals to I2 times. And here the L vector is L into JK, and cross B1 vector is, let me see, B1 vector is mu naught I1 upon 2 pi d, mu naught I1 upon 2 pi d minus of kk. This is the equation. Now the force F12 vector will be nothing but, here whatever is the constant we can take them out from the we can say bracket. So we can write here mu naught I1 I2 into L upon 2 pi d. And now what is inside the bracket? It is jk, or this minus will be outside, so minus jk cross kk. This is inside the bracket. Now this jk cross kk, we know that it is nothing but it is ik. So we can see F12 vector, it is mu naught I1 I2 upon 2 pi d into L, and the direction is minus of I cap. Minus of I cap, what it is pretending? Minus of I cap, it is saying that basically we know that the minus of I cap will be here. If we draw, minus of I cap will be in the this direction, minus of I cap, and this is the plus I cap. So we can see that the force due to conductor 1 on conductor 2 is towards the conductor 1. That means it is the attractive force. Okay. So we will see. So without, if we write it without direction, so here we can see magnitude magnitude of the force is F12. Its magnitude is F12 equals to mu naught I1 I2 upon 2 pi d. Okay, so the we can say the magnitude of the direction vector will be 1. So that's why. So force is nothing but and the okay, one thing is left, that is L, length L. This is the equation of force. There are, let me write here. There will be two equations, because first is the, we can say it is vector form, and the second one is in the magnitude form. The magnitude form is, okay. So these are the two equations of force. And what we can see now, similarly, we can determine from the second conductor also, like the magnetic field due to second conductor will be B2, and the force due to second conductor on first conductor will be F21. Similarly, we can find out if you want. Okay, let's find out. F12. Now, second point is the magnetic field due to conductor 2 to towards conductor 1. Okay, so there we can see that the current flowing in the second conductor is, let me write here the first conductor and second conductor, so you will not be get confused first. And this is the second conductor. So in the second conductor, current is I2, and the towards, we can say towards the second conductor, we want to find out the magnetic field. So again, we will apply the right hand thumb rule. So it will be, if the direction of current I2 is upward direction, so the magnetic field magnetic field will be out of the pace, towards the out of the pace its direction will be. So it will be plus kk. So the magnetic field will be nothing but B2 vector equals to mu naught I2 upon 2 pi d, and the direction is plus kk. Now we will find out the force due to conductor 2. Now the the magnetic force due to conductor 2 on conductor 1 is. So the magnetic force due to conductor 2 on conductor 1 will be F21. So it will be F21 equals to, so again we will apply the same formula, like the force due to a current carrying wire, that will be I1 times L vector cross B2 vector. So now we will put the expressions, then we will get F21 vector equals to I1 times L. Again, the direction of the currents are same in both the conductors, so that's why it will be L J cap only cross mu naught I2 upon 2 pi d, and the direction is kk. Okay. Now, when we solve it, we will get F21 vector equals to the whatever the constants are there, we can take them separate. So mu naught I1 I2 upon 2 pi d into L, and whatever in the bracket it is j cap cross kk. So the force will be nothing but it will be F21 vector equals to mu naught I1 I2 mu naught I1 I2 L upon 2 pi d, and what is j cap cross k cap? It is positive I cap. Okay. So this will be the force due to second conductor on first conductor. So if we see carefully that it is in the I cap direction. Okay, I cap means in the right direction. So we can see that the force due to second conductor on first conductor will be towards the second conductor only. That means both the forces like F12 and F21, they are equal in magnitude but opposite in direction. What does it mean? That means both the conductors are attracting each other. Fine. So both the conductors are attracting each other if the direction of current flowing in them is in the same direction. That means the parallel currents attract each other. We can make a decision that the parallel currents attract each other. So from equation number, let me write the equation here. This is equation number 1, and from equation number 2, equation 2, equation 2, we can say that, and okay, first of all, let's take the magnitude of it. So its magnitude, it will be F21 mu naught I1 I2 upon 2 pi d into L. This will be the magnitude. Now, now we can see that the magnitude of F12 and F12 and F21 both are same. So magnitude of F12 is mu naught I1 I2 L upon 2 pi d, and similarly F21 is also similarly. So therefore here F21 is equals to F12 in the form of magnitudes. Magnitudes are same. We can see magnitudes are same. Now in the vectorial form, we can see that F21, it is nothing but negative of F12. Okay, that we can see. And it is verifying also the which rule? Uh, Newton's third law. Okay, Newton's third law of motion, that says that uh, for every action there is equal and opposite reaction. So that is also following here. Okay, so there are some conclusions. Let me write. Conclusions are First is parallel currents attract each other. Because just now we see that the parallel currents are attracting each other because they are, we can say their forces are opposite to each other, and they are attracting each other. Now, secondarily, if we no need to do the derivation again, and we can see that the if the direction of like the direction is opposite to each other, direction is opposite to each other, or we can say anti-parallel. In case of anti-parallel, they will be repelling each other, because then the direction of two forces will be in the same direction. So that's why they will be repelling each other. So second point is second point is anti-parallel currents repel each other. These are the 2 points. Okay. And although the magnitude of force will be same, but they will be repelling each other. Okay, so that's all about the force between two parallel currents. And if you have any doubt, then you can ask, and we'll try to resolve them in the next video, or in the comment section. You can ask. Oh, thank you.